Some authorities claim that they have been able to track these signals to cities in Russia, and that's why they're very confident to say that it's Russia. Obviously, Russia has denied this. However, it is apparent that there's been a huge increase in plane jamming and spoofing since the war in Ukraine started.
Europe's navigation network is being pierced again and again by signal drops that last only a few seconds. The strangest part is their rhythm. They appear during office hours, then vanish completely over the weekend. Official reports may try to calm the public with familiar explanations: solar storms, hardware failures. But nature does not punch a time clock. A signal that switches on, cuts out, and immediately recovers looks far more like something guided by human hands. So are these simply random interference events that have not yet been explained? Or is the safest frequency band in the world being used as armor to drop intelligence data into hidden receivers waiting on the ground? Since 2019, air traffic control stations and telecommunications observatories across Europe have begun recording a chain of unusual events. At least 75 times, the global positioning signal from space suddenly dropped with severe intensity. This was not the failure of a single device. These were massive radio blind spots sweeping across the airspace of multiple countries at once. The first response from officials was to contain the panic. Official statements quickly reached for familiar natural and technical explanations: a solar magnetic storm disturbing the ionosphere, or a synchronized hardware failure across ground-based receiving stations. But the sudden disappearance of so many navigation signals could not be explained away by standard answers. Across online platforms and open-source intelligence forums, theories erupted almost immediately. Some observers speculated that Europe's skies were actually being hit by large-scale electromagnetic pulse weapon tests, a hidden move designed to cripple the continent's entire defensive radar network. Yet the real traces were not found in public statements or in the loudest speculation. They were buried deep inside technical measurement logs. And as the truth began to come apart layer by layer, it pointed toward a very different scenario. This was not the blind chaos of nature, and it was not a crude, continent-wide act of destruction. It carried the shape of something calculated. Professor Todd Humphreys and researcher Zach Clements at the University of Texas at Austin decided to trace the entire archive of data from Europe's global navigation satellite system, reference stations. When they looked directly into the raw radio streams, what they found cut straight through every official explanation. The first abnormal detail was the duration of the disruptions. When hardware fails or when space weather strikes, outages usually last for hours, sometimes even days before systems fully recover. But the signal drops across Europe followed a much stranger rhythm. They were brief. Most of these signal losses lasted less than 10 seconds. Then, almost instantly, everything returned to normal, the signal lines sharp again, as if nothing had happened. Imagine every traffic light in a city as large as New York suddenly going dark at the same moment, only for all of them to switch back on 5 seconds later with perfect timing. That kind of interruption is too clean, too precise, to be dismissed as an accidental system failure or a natural storm. But the second abnormal detail was what truly removed the environment from the list of suspects. When Humphreys and Clements mapped the timing of all 75 events, they found a pattern that made no natural sense. The interference events occurred almost entirely on weekdays, especially Tuesdays, Wednesdays, and Thursdays. More disturbingly, they lined up with the rhythm of office hours. A solar plasma storm can weaken radio signals. But since when can a cosmic event switch itself on and off within seconds? More importantly, nature does not know how to pause for the weekend. Machines do not fail on an office schedule. Weather does not follow a human work calendar. That cold pattern shattered every safe explanation. Clearly, someone was pressing the button. But that behavior left behind a massive gap in logic. Why would any force touch the navigation network of an entire continent, then pull back after only a few seconds? If natural events cannot follow the work week of human beings, then who or what is controlling these strange silences over the skies of Europe? Once mechanical failure and space weather had been ruled out, military analysts immediately turned to the worst-case scenario. If nature was not responsible, then human hands were interfering with Europe's skies. And the ultimate goal of such an operation usually points in one direction: a first strike meant to take down the West's navigation infrastructure. To understand why this network is so vulnerable, it helps to look at how it works. GPS signals are broadcast from clusters of satellites orbiting more than 12,000 miles above Earth. By the time those signals travel through the silence of space and the thickness of the atmosphere, most of their energy is already gone. When they finally reach the antennas on the ground, they are so weak they are almost nothing more than a radio whisper. It is like standing in the dark and trying to see the faint glow of an ordinary light bulb, except the bulb is farther away than the width of the entire planet. The GPS system keeps working only because it is constantly listening for that invisible, fragile light. But when experts extracted and analyzed the data from the 75 signal drops across Europe, they uncovered a truth that broke the theory of a full-scale destructive attack. The strange wave sweeping across the continent did not appear designed to crush the original system. Radio scanners measured this source operating at exactly 1,577.5 megahertz. The L1 center frequency, the core frequency used by the GPS network, sits at 1,575.42 megahertz. The unknown source had deliberately slipped about 2 megahertz away from the heart of the navigation system. In the world of space telecommunications, a 2 megahertz offset is not a machine error or a case of poor targeting. It is a sharply tuned, deliberate deviation. Imagine a force trying to stop a freight line. Instead of dropping a massive block of concrete directly onto the tracks and making the train crash and derail completely, it chooses another approach. The block is placed just outside the edge of the rail. It is close enough to scrape, to shake the system, to disturb its speed, but far enough away to keep the train from being torn apart. Some military telecommunications researchers have suggested that this off-center position may carry decisive strategic meaning. Instead of striking straight into the core of the system, the source appears to be keeping a calculated distance from the original GPS signal. The logic behind that calculation is brutally practical. If the radio wave hit the center of the navigation frequency at high power, Europe's guidance system would freeze almost instantly. Air traffic screens would go dark. Thousands of civilian flights would lose reliable direction. Warships would lose target coordinates. That level of disruption would immediately trigger the highest level alarms. NATO would be forced to treat it as a direct act of war and respond with the kind of military action designed to eliminate the source. But by transmitting just slightly off target, whoever stood behind it slipped around the red line of war. No system collapsed completely. The off-center placement turned the mysterious wave into a shadow. The hidden actor could test broadcasting capability, or repeatedly send an unknown signal, turning it into a faint layer of background interference, silently clinging to the side of the GPS system without triggering direct interception scenarios. An attack usually aims at the bullseye to finish the target, but what was happening over Europe carefully avoided that kind of destruction. If the goal was not to destroy the navigation system outright, then what was the strange source trying to do by staying so close to it? Identifying the off-center position of the radio wave did not bring an answer. It pushed investigators into a new dead end. Satellite navigation frequencies are among the most protected and tightly monitored regions on Earth. Even a minor radio irregularity there can trigger warning systems across multiple countries. So, why would an intruder openly choose to operate right next to such a forbidden zone? At first, some Western intelligence experts saw this as a psychological move. They argued that it was a public act of intimidation, designed to probe the response time of NATO's air defense radar stations. In this view, the adversary wanted to see how long it would take the West to detect the interference and how quickly interception systems would be deployed. But when military analysts placed real interception scenarios on the table, a colder truth emerged. NATO was not simply slow to respond. The essential nature of the civilian navigation band itself had tied the hands of the defense forces. Imagine a hostage situation. The armed man does not hide in a forest or disappear into an underground bunker. Instead, he stands in the middle of a medical center running life support machines for thousands of patients. The special forces have more than enough firepower to take him down. But if they throw a flash grenade into that room, the power and machines keeping people alive could fail with him. The situation unfolding across Europe's radio spectrum works in almost the same way. Ground stations in Europe possess powerful electronic warfare systems. In theory, they could actively broadcast intense counterwaves to suppress, jam, or completely drown out the strange signal. But any active defense effort inside this frequency region carries the risk of self-inflicted damage. The reason lies in how deeply modern society depends on it. If defense forces decided to flood that 2 MHz offset zone with high-intensity radio energy, the turbulence from that response could spread outward and choke the original GPS band itself. Those counterwaves could blind the guidance systems of thousands of commercial flights moving through European airspace, cripple maritime routes, and break the logistics network of an entire continent in an instant. The West would be trapped. It could not disable its own sky just to silence a signal that appeared for only a few seconds. The investigation escalated into something more disturbing. The unknown source's choice of frequency was not reckless stupidity. It was a strategic move calculated with ruthless precision. Whoever stood behind it had identified one of the deepest weaknesses in Western security. The more important a region is, the more dangerous it becomes to strike back. The source no longer needed true invisibility. It used the survival value of civilian infrastructure to build itself an unusual shield. By hiding beside something no country could risk shooting at, the strange wave created an absolute safe zone over Europe's head. Behind that shield, it could maintain its scheduled activity again and again without facing any physical resistance. The helplessness of the counter-strike systems forced analysts to step back. When force is neutralized by the risk of catastrophic collateral damage, the only remaining path is to collect fragments of raw signal and bring them into the lab. Protected by the shield of aviation safety, what was really hidden inside that brief block of signal? It was not until February 2026 that the true physical shape of the strange signal was finally exposed. Catching a block of radio energy that appeared for less than 10 seconds, then vanished across an entire continent, was a massive technical challenge. But by comparing and successfully extracting raw radio samples from 2 independent receiving stations, one in Amsterdam, in the Netherlands, and the other in Trondheim, Norway, researchers finally captured the core evidence. For the first time, the invisible wave sweeping across European airspace appeared clearly on a spectrum analyzer. Before this data was released, many military analysis reports still held to a safer explanation. They suggested that these 3-second signal drops were only the leftover traces of an equipment test. Some new weapons platform in space had been switched on and then shut off quickly just to test the stability of its electrical system. But high-resolution radio spectrum scans immediately revealed one detail that pushed that scenario aside. When an ordinary jammer operates, its purpose is to destroy information. It throws out chaotic bands of radio energy, spreading disorder like white noise to choke everything around it. Imagine someone turning on a massive alarm siren just to drown out a conversation in a room. But the wave sweeping across Europe did not carry that kind of brute force signature. It had a strangely clean shape. This block of signal was deliberately and precisely confined inside a bandwidth of about 5 MHz. Its edges appeared relatively sharp, with no messy energy leaking out to either side. In the world of space telecommunications, 5 MHz is not just a random patch of noise. It is comparable to the kind of bandwidth used to maintain a high-speed data stream. If designed and modulated as a transmission channel, a 5 MHz band lasting for several continuous seconds could physically carry a massive amount of information. Imagine that instead of throwing a cloud of smoke, the source was dropping a tightly compressed hard drive. In those few short seconds, that 5 MHz space could hold thousands of pages of encrypted intelligence files, detailed coordinate maps, or complex military command strings. Its physical structure looked less like an attack and more like a data relay channel. That realization pushed the entire investigation onto a different track. When analysts widened their scan to determine what this block of signal might be targeting, they uncovered something no one expected. This off-center band was not only obscuring the western sky, the spectrum data showed that the signal was also directly overlapping with the Beidou system. China's strategic satellite navigation network, one of its most tightly protected systems. Even more striking, archived data confirmed that this phenomenon had been quietly happening since mid-2020. If the unknown source was purely a destructive weapon, a major contradiction appeared immediately. Why would a suspect satellite network risk a geopolitical rupture by striking not only Western navigation systems, but also the strategic navigation system of its own partner? What possible gain would be large enough for the actor behind it to interfere with both rivals and allies? That contradiction cut directly into the theory of an attack campaign. The breach of the navigation band did not appear to be aimed at destroying radar systems or threatening air traffic. It strengthened a more systematic possibility. The global navigation frequency itself may have been only a screen, hiding an underground communications line. The forbidden zone of the radio spectrum was being borrowed as a runway for dropping data. And if those brief pulses were truly carrying intelligence files instead of noise, then who on the ground was quietly hiding, waiting to receive them? Using time difference of arrival analysis, or TDOA, across independent receiving stations spread over the continent, researchers began tracing the invisible signal backward. They measured tiny fractions of a second in the way the signal reached the ground, using those delays to reconstruct the angle of the radio sweep. The final lead did not point to a fixed radar station on the ground or a spy plane hiding in the distance. It pointed straight into orbit. The captured spectral trace matched the coordinates and transmission direction of Russia's EKS early warning satellite network, operated by its space forces. These were not communication satellites racing quickly across the sky. The EKS system is designed to operate in Molniya orbit, a highly stretched elliptical path. Imagine a flight route shaped like an egg. As the satellite moves toward the northern hemisphere, it reaches far out from Earth. At the top of that orbit, weaker gravity slows the movement of the multi-ton spacecraft dramatically. That physical effect allows an EKS satellite to almost hang over one region for hours at a time. From that altitude, it has enough time and enough angle to cover an enormous territory, easily pouring radio signals down into any country in Europe. But the presence of a military machine in orbit was not the most frightening detail in the report. A transmission system only matters if someone is there to receive it. The central question of the investigation now moved from the sky to the ground. If these 5 megahertz bandwidths, packed with data, were repeatedly being released over Europe, who was quietly waiting to download them? In traditional defense thinking, receiving intelligence data from space requires massive infrastructure. That usually means dish-shaped radar complexes dozens of yards wide, demanding huge amounts of power and easy for enemy reconnaissance systems to photograph and locate. But this strange signal changed the rules entirely. By deliberately slipping 2 megahertz away and hiding along the edge of the civilian GPS band, the source gave the receiver a ruthless advantage. The equipment needed to listen to that band did not have to be a specialized military facility. Because the frequency sat so close to ordinary navigation signals, commercial antennas already on the market could theoretically be tuned to catch it. In theory, a specialized radio receiver, if built with the right circuit board and decoder, could be shrunk down to the size of a suitcase. That compact size could turn an entire continent's infrastructure into a hiding place. An intelligence receiving station could sit silently inside a steel drum in the back of a freight truck speeding down the Autobahn. It could be buried inside an underground cable maintenance station in London, or blended into the thick forest of civilian antennas on the rooftops of Berlin apartment buildings. The rapid on and off rhythm of just a few seconds may have been the narrow window these devices needed to wake automatically, absorb the entire block of data, then cut power and sink back into sleep mode before any air defense scanning team could locate them. The shield created by international telecommunications law had stripped away the ability to shoot down the source in the sky. Now, the evolution of miniaturized receiver technology had taken away the ability to easily find the target on the ground. In a world where radio devices can be disguised beneath countless harmless civilian covers, how can anyone know what is only an ordinary navigation system, and what is an ear quietly waiting for the sky to speak?